Oops. Okay, great. Hi, everyone. I'm Mark Ferguson. I'm a wildlife biologist with the Vermont Fish and Wildlife Department. And I just wanted to talk with you a little bit today about a project that I'm doing on the Lomoil River with funding from the Lake Champlain Basin program. My project is conservation of the Lomoil River mudpuppy population using translocation and monitoring. But before I get into the project itself, I just thought I'd give you a little background on the mudpuppy. You know, what is a mudpuppy? Why are we interested in it, and how it's doing in Vermont? So this is actually our largest salamander in Vermont. It can get to over a foot long. I think the longest one I've caught so far is about 15 inches. So these are pretty large. It's also our only totally aquatic salamander. So these never leave the water, where, you know, we have a lot of salamander species that will lay their eggs, have their larvae in water, but when they reach their juvenile stage or adult stage, they'll absorb their gills and generally leave the water for terrestrial habitats. Mudpuppies don't do that. They never leave the water, and as adults, they retain their gills, as you can see in that picture there, those big fluffy feathery things behind their head. So in Vermont, mudpuppies, their natural populations are limited to the Lake Champlain Basin. So they're found primarily in the lower parts of the tributaries, large tributaries of the lake, and in portions of the lake itself. It also has a natural heritage rank of S2, indicating that it's considered a rare species in Vermont, and it's included in our State Wildlife Action Plan as a high priority species of greatest conservation need. So where do these guys live? They're basically found in rocky areas of rivers, and where you find that in some lakes. In Vermont, that's just Lake Champlain. One of the reasons they like these rocky, kind of clean substrates is that they tend to do a lot of hiding, and to do that, they need to be in cavities formed by rocks or other cover items. And this is where water quality plays a role. So you don't want to have a lot of excessive sedimentation, you know, fine sediments coming down through a system where you have mudpuppies, because this is a risk of filling in those those cavities under the rocks. And if they, you know, if these cavities get filled, mudpuppies can lose their hiding spots, making them more vulnerable to predation and other forces. And another reason that these cavities are important is this is where they have their nests. So a female will lay her eggs in one of these cavities, attaching them to the underside of the cover item she's hiding under, and guard the nest, the eggs, as well as the young, the larvae, once they hatch, until they're ready to leave. So again, very important that these cavities during the nesting season remain free of excessive siltation, because that can affect the survival of both the eggs and the young. And as an amphibian, mudpuppies are also sensitive to water pollutants. So, you know, having permeable skin plus these gills, they do absorb chemicals and are actually considered a bioindicator for water quality. I love those gills. I can't stop watching them. They're just cool. So how do they fit in their environment? What do they eat? They eat primarily small food items. They eat a lot of aquatic insects, crayfish, other aquatic invertebrates, as well as small fish like minnows. And in turn, they can be eaten by things like semi-aquatic mammals, minks, otters, as well as wading birds, great blue herons, and predatory fish. So that's just a little background on the mudpuppy. I'll move into my project now. We had two main goals. The main one was we wanted to enhance the resiliency and the long-term viability of the Lamoille River mudpuppy population. And we're going to do this by establishing a novel subpopulation upstream of where they naturally occur. So basically, we're going to be trapping individuals from where they currently are, taking those individuals, moving upstream to a new site, and trying to establish a new population up there over time. And this is also a good opportunity for us to increase our understanding of mudpuppies, in particular, their movements and their migration. And to accomplish this, what we did was we've taken a subset of those animals that were moving upstream, fitted them with radio transmitters before they're released, and then once they are released, I'm in there using radio telemetry equipment to track their movements. So we really didn't have any experience with tracking or trapping mudpuppies. We wouldn't have known what to do, what would work well in the Lamoille River, but fortunately, there had been a previous UVM study that worked all the details out for us. In this study, they did confirm a trapping method that worked well in the Lamoille River, among several trapping methods that are used elsewhere. And also very importantly, and the reason I put this slide up is they mapped out when they had really the best success in their trapping. So they trapped from December through the end of April. And what I want to draw your attention to in this rather complicated looking graph is that period from late March into April. And those vertical bars represent the number of mudpuppies they caught, two different colors because it's 2 different years, 2009 and 2010. And you'll see that in late March, the size of those bars indicating the number of mudpuppies they caught really starts to increase. And this coincides with an increase in the water temperature, which is represented by those dotted lines. Again, 2 different colors for the 2 different years. And so as the water temperature rose, and we're not talking about warm water by our standards by any means, but we're talking about a rise to about 2 to 3 degrees Celsius. When it got up to that range, you start to see increased catch rate. And that's because this is a species that tends to start moving a lot in the springtime. They found that once the water temperature got up to about 6 degrees Celsius, catch rate started to decline. And then when it got up to as much as 10 degrees, they really didn't catch many mudpuppies at all. So I use this information to really focus my efforts. So I trapped from that late March, second half of March period into April, and that way I could maximize my catch of mudpuppies for the time I could spend on the river. So here's a shot of the most upstream trap location. That's Peterson Dam you're looking at there, and you can see that we were out there during the cold part of the spring, and often when water flow was pretty high, which also tended to be or tend to affect trap rates. So if you had some precipitation event, you tended to catch more mudpuppies shortly after that. And we so from this is the highest, the most upstream point. We trapped downstream for about a half a mile from here. And this view just indicates our release site. You know, once we had trapped them, taken the information we needed, we took them upstream. To the left of the arrow, which is our release site, you see the top of Arrowhead Mountain Lake. So we put them into a spot that I deemed as probably the most similar habitat of that available, similar to where we had trapped them. I'll show you this large-scale map just to show you that if they decided to move upstream from the release site, they had 6 miles of river without dams that they could access all the way up to as far as Fairfax Falls. So how do we go about our trapping? We used minnow traps, which we baited with dead golden shiners. These were tethered to the shore by a rope. We placed them out in the river and checked them every 24 hours. We had a total of 24 traps. Once we check them, we'd take any mud puppies out, replace the bait with fresh bait, and put it back in the river. And again, we did this, through that starting in mid-March into April. That inset just shows you where we set our traps. 24 traps, 8 in 3 different areas just downstream of the Peterson Dam. So once we captured mud puppies, we took them back to the Sandbar Wildlife Management Area facilities where we could work them up indoors. Here we took measurements. We got a length, a weight. I determined the sex of each animal, take a couple of photographs, and also I would insert a pit tag into the tail section of each of these, which is just a way of identifying that animal later if we ever went in and did another trapping study at the relocation site. So once we were finished getting our data, we took them to the release site, put them into the river, and you can see here it's a rivering environment, not really fast water, but very rocky. And again, this is just what seemed to be the most appropriate habitat of what was available upstream of the reservoir, or I should say most similar to what we took them out of. And again, for a subset of those animals that we moved, we fixed them with radio transmitters. This is a salamander. It's got a slippery skin. There's really no way to affix a tag to it or to put a harness on it that would, not slip off. So this has to be done internally. So we would anesthetize each animal, make a small incision in the abdominal wall, just large enough to slip radio transmitter in. It's fairly small transmitter, gosh, I don't know, about an inch, a little over an inch long. Suture the site back up. And once it had resuscitated, we held it overnight we held it for 24 hours, examined it the next day, make sure it looked healthy, that the incision area looked good, and that the sutures were holding, and then release it the day after we did the surgeries. Once we had our radio tagged animals in the river and trapping had ended, it was time for me to shift over into my tracking phase, my radio telemetry work. My original plan was to do this from the bank, as you see here. That didn't turn out to work out as well as I had hoped. My transmitters were rated for a detection distance of up to as much as a quarter mile. I knew I wouldn't get this because, first of all, I was putting them underwater. Secondly, I was putting them inside an animal, and then that animal was likely to be hiding under a rock. So, that was all going to affect my detection distance, but it affected it more than I'd hoped. And in some cases, I wasn't able to detect an animal for more than 150 feet or so, and this didn't even get me halfway across the river in some spots. So I needed to find another method. So instead of doing it from the bank, I employed the use of a kayak, which was a little awkward, but actually worked out really well. And it turned out to be the better method because whereas from the bank, I would have had to triangulate to get some estimation of where I thought the animal was. Whereas from the kayak, I actually could paddle around, holding my antenna out until I could actually locate exactly where I thought that animal was, where I was getting the strongest signal. So I think it was actually turned out to be a much more accurate method, at least for the portion of the river that was boatable. So this is a 2-year project. Last year was the first year. What did we get? We had a very successful trapping season in 2022. Got 114 mud puppies that we captured and moved upstream to the relocation site. This far exceeded our minimum that we had set. We were going to move at least 50 animals, but we also have a cap on the project of 150 that we can move. So this leaves me 36 animals that I still had remaining to me for the 2023 season. Now I've never done telemetry before. This first time I've used it, and I kind of felt like I needed to get some experience before I put all my transmitters out in the river. Plus, I really didn't know what these mud puppies were going to do when they got out there. So I wanted to just have kind of we'll treat 2022 as kind of my pilot year, see how things went. So we put 6 transmitters in mud puppies and then released them. And then when my tracking started, well, we got our transmitters out in the river at the end of March, but we continued trapping through the month of April to get that 114 animals. So there was quite a lag between when we got the transmitters in the river and when I was actually when I started my tracking. And by that time, the water had warmed a bit. And when I did get out there, I was only able to find 3 of my 6 radio tagged mud puppies. Now you can look at that 2 ways. It's good. I mean, I wasn't sure if I'd find any of them, so I did find 3. So that was great. But there were 3 missing, and I never did have any sign of them. They never showed up at all. So that was kind of a mystery at that point. So when I did get out there, the water had warmed a bit, like I said, and I wasn't really seeing any movement. So from June through October, I just didn't see any movement at all. They just sat in one place. I didn't know if they were alive or dead, which was one of the things I wanted to know is would they survive. But that wasn't really unexpected. I knew there wasn't going to be much movement during the warm part of the season, so I didn't get worried about it. And sure enough, November came around, all 3 of those individuals started moving around a bit more. And that's what is represented here. That larger oval represents where I found 2 of the animals. And I should say that this is actually right where the release site was. The 2 bridges, there's a railroad bridge downstream to the left, and then upstream of that is a road bridge. The release site is on the north bank between those 2 bridges. So those 2 individuals stayed, at least during the time I could detect them, they stayed pretty close to there. That oval indicates the range that I found them within during that time in 2022. And then the 3rd one moved upstream early on, about 1,000 feet. It also moved kind of up and down the bank parallel to the shore, but it stayed within that area. So for 2023, I needed to, just assess and figure out my approach for the second season. As I said, I had a maximum of 36 remaining that I could catch. I wanted to increase the number of transmitters that got out in the river this time, now that I had some experience with it, so double the number to 12. And I knew that I needed to improve my early season detection. Again, I had several animals that were not detected. Plus, I got out there late enough in 2022 that I didn't get that early season movement. So I shifted my focus a bit from the previous season. Instead of trying to trap as many animals as I could, instead of trying to capture as many as I could, I wanted to get out on the river and start my radio telemetry work as soon as possible after I had those animals with transmitters released into the water. Now, I kind of expected this to be a short trapping season anyway. I mean, in 2022, 36 animals, there was a period where I could have gotten this in less than a week. So, I knew I could end up getting all 36 of my animals before I even got the transmitters out in the river, and that would be fine. But when the March 23 arrived, so did the cold, and it just hung on. We had shelf ice along the shore much longer than we did in 2022. The water temperature remained chilly, and this was reflected in our catch rate. Whereas in 2022, during March, we averaged over 8 mud puppies every 24 hours, or every 48 hours for those 24 traps. 23 in March, we were down to 1. So every time we checked those 24 traps, we'd have from 0 to 1 mud puppies. So it was slow going, and I had to add an extra week onto my trapping. But eventually, early March, temperatures rose a little bit. We started to get more, and we ended up with a total of 20 mud puppies, enough for the 12 transmitters. So that was successful. And I was able to get out and start my tracking much earlier in 23. Got out there on April 13th, the week after the last of the transmitters got into the river. And this just represents where those animals are located on that first day. Again, the release site is on the north shore between those two bridges. So you can see most of the animals are clustered pretty close to there. With one exception, there was one that was along the south shore, about 750 feet away, but still pretty tightly clustered in there. So I felt like I did a much better job with this earlier start date. But still, I only found 10 of the 12. There were still 2 missing. So that was kind of a mystery. You know, what happened to those? I don't know, and they still haven't shown up. So that was my first date. A week later, different picture. There's quite a bit of dispersal going on here. And it's going in both directions. That's what's interesting. I have animals going upstream into fairly fast flowing water. The most upstream one on the right side there is actually what I would have classified as rapids. First time I'd seen any access water that fast. But on the other hand, I had another one on the left side there. They went way down into the lake. It was at the head of a brushy island in what I would not have considered mud puppy habitat. So, you know, it's unknown what took it in that direction. You know, I certainly don't think it was going to be residing there long term. Then a week after that, the trend continues. The one that was moving farthest upstream continued trekking up into that faster water, while now I had 2 animals down in the reservoir to the left, even further down in the reservoir. So this was basically about a mile stretch of river / reservoir habitat that they were accessing. At this point, I was thinking, okay, now it's going to start getting challenging. I could start losing animals just through, you know, not knowing where they're going. The lake widens beyond this, and with a short detection range, I wasn't sure how well I'd be able to get them. And I should mention also that I was also, I don't know if you can see it on the very right side of this picture, it looks like a ledge that's going across the river there. That's exactly what it is. And I don't know if it's a barrier to movement. I don't think it's necessarily a complete barrier, but it's certainly impediment to movement, or at least I thought so. And so one of my animals actually got all the way up there. But anyway, with the possibility that they could get past that, I was walking the bank for another half mile upstream of that ledge, and did that last year, did that this year, never have had any detections. So anyway, you know, I'm thinking, all right, here's where it gets rough. But then they surprised me again. A week after this, the 2 that were down in the lake moved back up towards the bridges, towards the release site, where the others were located. And while that one that was farthest upstream did for another week continue trekking upstream, then it also started moving down towards the bridge. So I don't have pictures of all the weeks since April 28th, but basically here's a month later. Scene has changed quite a bit. Again, I get that clustering between the bridges, and I have 2 upstream, but again, it's faster water up there, but it's not really fast flowing like they had been in before. So this is actually a lot like what I saw in 2022, where they've ended up to this point. They're clustered in two areas, one around the bridges and the other just upstream along that north shore. So that's interesting. And I did have one additional animal that disappeared kind of from the middle of the pack. It hadn't been moving much, but suddenly it was just gone. So, what's going on with the pattern here? I don't really know, why they moved out and why they came back, but I do have kind of my working theory has to do with site fidelity. There are, a lot of reptiles and amphibians are known to have pretty high site fidelity. You may have heard, if you're kind of a nature geek like I am, you don't want to take a turtle, like especially a terrestrial turtle, from one area, take it home somewhere else, and then release it somewhere, because it's really homed in on its home range. And if it's taken somewhere else, it will wander great distances trying to find familiar ground again. And misdemeanor salamanders, things like spotted salamanders and Jefferson salamanders, are known to, once they reach adulthood, go back to the same vernal pool for breeding year after year after year. They really, they know that site. They know their habitat. They home in on it. So, I think that could be an explanation of what's going on here. I took these animals from downstream to an area that they're very familiar with and brought them up. So even though I put them in habitat that I considered similar, it was still kind of an unknown environment to them. They weren't, they probably didn't recognize whatever landmarks Mudpuppy uses. So they started straying, looking for home, going in both directions, even though it was kind of two different, very extremes in the habitat. Fortunately for this project, they seem to have, it seems to me that they recognized they weren't finding what they wanted, and they came back to the area that I had originally put them. Again, this was flowing but not fast water, a lot of rocky habitat right here. So I think, to me, I think that's at least a plausible explanation. And then there's the other question of what happened to those animals that disappeared. I never got it, other than the one that disappeared while I was, after I attracted. The other 5, there's just never had any sign. But and it could be that they just moved out of the area, like I had said before. That's a possibility. Although this, what I found this year with these animals kind of coming back towards where I'd released them, it kind of makes me question that. A couple of weeks ago, I did get a clue, though, that could explain some of it. And it has to do with one specific individual. If you look, there's one that's just found to the right on the north bank of the bridge there, that white bridge, found up along the bank. I don't know if you can see that or not, but that it was found right up against the shore. That's where I was getting the signal. And let me just go back in time again. A month earlier, it was there. That's where it was. And a week before that, it was there. And the first time I was out, that's where it was. And I had noticed this while I was tracking that while the others were moving around, this one didn't seem to be. And it was also kind of odd because I had trouble finding the exact location of this animal, even though it was in shallow water, right up against the bank. I couldn't, hold my antenna over one spot where I could say, this is a stronger signal. I knew it was right there, but it just wasn't as obvious as a lot of my other animals had been. Then a couple of weeks ago, I was out there and I got my clue because I was at that spot, and who should I see hopping up and down along the bank? Mr. Mink. The light kind of went on for me. I said, okay. And this inspired me to take my telemetry equipment, get on my boat, and go up on the bank. And sure enough, the signal had been coming from up on the bank right beside the entrance to a mink den. And I couldn't find the tag on the ground. So I think it was actually underground in the den. The mink had likely caught the Mudpuppy early on because that signal had never moved from that spot. I think, almost as soon as it was released, caught it early on, took it down to his den for a snack, and took my transmitter with it. And it kind of stinks that he got my transmitter. But on the other hand, this is really what I had these transmitters in these animals for, is to find out this sort of thing. And I never would have been able to pinpoint predation as, a definite source of mortality unless I happened to find a mink with a Mudpuppy hanging out of his mouth, or a great blue heron flying away with one, something like that. So it was good information. I guess I don't begrudge him my transmitter. So that's kind of where we are right now in this project. It's an ongoing project. It ends this year, so I'll continue with my telemetry work through this fall. I'll probably continue late December like I did, or early December like I did last year. And I'll probably get out again next spring, see if any of my radio tags batteries are still alive. I'll go out and just see if I can get any information on that early spring movement. And then as far as future work goes, it'd be great if we continue looking at survival of these released animals beyond 1 year time. This would probably take another trapping effort, but this time within the release area. And also, over time, even beyond that, looking at potentially recruitment into the population from successful reproduction if we get any. So that's about it. Happy to answer any questions you have.
Thank you, Mark. That was really interesting. We do have a couple questions in the chat. I'll read them for you. So the first question is about the radio transmitters. Were they battery operated? That's been this person's experience. In which case, what was the time frame of operation for each transmitter inserted?
Yeah, so these are battery operated because they're inserted internally. They have to be encased within, the whole thing is encased, the whole little operation there, battery included. So they should be watertight. The way I had these set from the company that produced them, I had them with a low pulse rate, which meant I could, I think it was I got a pulse every 3 seconds, if I remember right. No, every 2 seconds. Sorry, every 2 seconds. So I get 30 pulses every minute. That was the lowest option I had, but it meant that my battery life would be maximized. So they were rated, I may not get the exact numbers, but I think it was anywhere from like 190 days to more than 440 days. So that's why I'm thinking, I could still next spring have a few of these transmitters still viable out there and still detectable. I went out this spring looking for last year's animals also. I detected one of them. It was during the middle of our trapping period, that 3-week period we were trapping. Got one signal basically from the same location had been before, but a week later I couldn't detect it, and I never found the other two either. So, I think that was probably just the batteries going out.
Another comment says, "Thank you, Mark. This is an awesome presentation. Why are mud puppies restricted to the Lake Champlain basin, and is there unoccupied potential habitat for them in other basins in Vermont? How do flooding and fluctuations in water level and velocity affect these animals?" It's 2 questions. One.
Okay. So starting with why are they limited? It's the same pattern you see in a lot of animals. Once you get down below what we call the principal fall line in the Lake Champlain Basin, you see a great increase in aquatic diversity. And that fall line is basically where, if coming upstream from the lake, you get that first fall line, or that first waterfalls, or cascades that's large enough to impede a lot of upstream movement from animals. So it's a geologic feature. Oftentimes they have a similar elevation throughout, as you go north to south, or else at one time had a similar elevation, because you do have rebound over time that was different. So that's why mud puppies are, at least we think, are restricted to areas below, or the lower sections, because it's that fall line. Sometimes we get surprised. Some species that we think are fall line species, turns out they're upstream as well. I've seen that with some freshwater mussels. Don't know the whole picture there. But yeah, that's why. And then another question was, are there other opportunities, I think, for similar work in other tributary or in other watersheds? Yeah.
Are there unoccupied potential habitat for them in other basins in Vermont? Was that part of
Yeah,
the
I think
question.
there certainly are. And in fact, we had the Polteny River as a fallback on this project, in case for whatever reason we weren't able to collect enough in the Lamoille River. We knew that we had a population in Polteny also, so we were going to do something similar there. The Lamoille River has what we think is by far the largest population of mud puppies in Vermont, so that's why we stuck with the Lamoille. But yeah, if this is successful and we want to do something similar, mud puppies are found in the Missisquoi, Winooski, historically in Lewis Creek, but they haven't been seen there in quite a long time, and the Polteny. So, if this turns out to be, successful and something we want to continue with, there are other opportunities. And then I forgot what the third question was.
How do flooding and fluctuations in water level and velocity affect these animals? Was their part of the question.
Yeah, good question. And I don't really have an answer for that, but it was, certainly I was getting some insights, I guess, in this project, just, from the relocation. These are benthic creatures, and as I said, they're under rocks. So they're typically able to find refuge from flow because of this. So, even though I said that I had a couple animals that are going up into fast water, they're probably doing it in a way that they're avoiding what, the flow that we're seeing. They're, once you get down to that benthic part of the river, flows are much reduced, and they can easily work their way upstream. So I think if you have fluctuating water temperatures, they can find a way to maneuver around that.
Thank you. So we have a couple more questions. Someone asked, based on what you've learned about their movements and potential site fidelity, what do you think is the impact of artificial barriers in the river on mud puppies generally?
Certainly, they're not going to make their way around barriers. This is an aquatic animal. And while they may be able to work their way over short distances out of water, so like if, they're caught in a side channel or something, they may be able to move over rocks and get back to the main channel. But certainly any barriers are going to impede their movement upstream. And Peterson Dam is an interesting one because it's not actually on the fall line. I think it's our only Lake Champlain dam. Well, no, I take it back. There are a couple. That one and the Swanton Dam are not on the fall line. And we don't really know if we had mud puppies that still exist upstream of Peterson from there up to the Arrowhead Mountain Dam. It's possible. I don't know if the habitat's there or not.
Another question asks, with some of these large rivers, are the mud puppies susceptible to nutrient enrichment due to stormwater and agricultural runoff?
It's an unknown for me anyway. I would expect it is just because mostly because it's going to change their habitat and potentially, things like oxygen content. So, that's a factor. Mud puppies can make it in lower oxygen areas, or I should say, I wouldn't say low oxygen environments, but they actually can increase the size of their gills if they are experiencing lower oxygen environments. So, those gills will increase so that they have more surface area to intake oxygen. But I would say, they, like I said, they're considered a bioindicator. They do need cleaner waters. And certainly if you have anything approaching an anoxic environment that you might encounter due to nutrient enrichment, that could be a big factor. And then just the fact that sort of situation is going to affect their habitat as well. And, potentially things like nest survival of eggs and their young. I don't really have any information on it, but there have been a few studies showing that at least for there are some contaminants that do bioaccumulate in mud puppies, and that's one of the reasons they're considered a bioindicator. But yeah, I would think nutrient enrichment could be an issue.
There are no more questions in the chat right now. But if anybody else who is on the call has a question and wants to raise their hand or put it in the chat, we still have a couple more minutes till 12:45. Emily.
Hi, Mark. This was an awesome talk. Thank you so much. Was interested to hear a little bit more about when you're looking about relocating mud puppies to establish new populations, like what some of the environmental factors are of how you optimize the sites for them. There was some mention of nutrient enrichment and artificial barriers, and some of those environmental conditions also relate to some of the water quality and clean water implementation efforts that we're also many folks here are also working on. So I was curious if you could speak a little bit more to those considerations.
Yeah, I'd like to say that we had a long period to figure out how we're going to go about this project, but it happened pretty quick. And this project actually kind of came from another effort that was done. We actually did our first transfer of animals back in 2020. The secretary wanted us to do this project after discussions with the Endangered Species Committee, looking at mud puppies and concerns over its long-term viability. And this was one of the suggestions that had been made through the Endangered Species Committee, that we try to establish one of these populations upstream of the existing one to see if that would work. So I was kind of given that task in short order and didn't have a lot of planning. So it would have been great. I mean, even things like, gosh, just make sure we don't have mud puppies where we're putting them before we put more on top. I don't think there were, there's not much possibility that they were there, but we just didn't have a lot of planning. So it would have been great to address some of those things, making sure that, okay, is this good habitat that we're putting them in, or potentially good habitat? And, are there issues that we need to be considering other than just, visual inspection? But it's not very far upstream. I think the dam, Arrowhead Mountain Dam, is about 3.5 miles upstream of our collection site, and our release site is another 3.5 miles. So 7 miles upstream of where we had been. So certainly, I think the river is fairly similar. And I mean, I wouldn't even try to speak to water quality because you guys would have the information on that. But similar in many respects. I don't know how familiar any of you are with Arrowhead Mountain Lake, but the top of it is pretty silt laden. The substrate, it's pretty shallow, and you can see just by the the shape of the lake that you have a lot of wetlands up in there, a lot of cattail marshes, and it's just kind of an odd looking reservoirs. And I don't know, but I have always kind of assumed that's because you had sediments coming down in there over time. It could have been natural topography. I don't know, but that doesn't seem to have been. Well, I guess for the habitat that I can see upstream, and again, it does get shallow in areas, so you can see the substrate pretty well. There's not a lot of sediment deposition where I can see. So it seems like it was good habitat. It struck us that way. So, that's kind of what we went with.
Someone asked, could this work be supplemented by the U.S. Fish and Wildlife Service in mitigation for lampricide applications?
I would say that's, totally different part of mud puppy conservation kind of outside of this. I can't really speak to the lamprey program, kind of a touchy subject. So I guess I'll just, kind of confine myself to the current project. That would be a question, I guess, to ask U.S. Fish and Wildlife Service.
Another question is there any potential for eDNA detection of the novel population after your transmitters die?
Yeah, and we've actually used eDNA, or had a pilot project for eDNA in the past. This was kind of a jumping off point from, or was jumping off point for this. We did an eDNA study that took samples from a number of Lake Champlain tributaries. Somewhat successful. We got, positive from the Lamoille River, a negative for a couple of other streams where we either had historical population or we knew that there were an extant population. So it's kind of a work in progress, I think, for eDNA. I'd heard in the past mud puppies seem to be a bit challenging in other states that have tried it, but there's been a lot of progress recently, and I know there's more work out there now for eDNA, and it's certainly got a lot easier than it has been in the past. My department's starting to utilize it for a lot of things, even fish community type work, multiple species. So I think there's definitely a place for it there, as far as trying to figure out the success of this project. So yeah, short answer, yes, I think eDNA could be a benefit for looking at the long-term success of this project.
Thank you. And I'm not seeing any more questions in the chat or any raised hands, so we could wrap up now. Thank you so much, Mark, for coming and sharing your work, and for everybody who came to listen to this conversation. This conversation will be on our YouTube later today or tomorrow, so you can go back and watch it again as many times as you want. All right. Thank you, everybody. Have a good rest of your day, and a good weekend.
Thanks a lot.
Thank you
too.
so much, Mark. Thanks, Rachel.
Bye, everyone.